For my major work this year, I've chosen to produce a queen-size bed frame made from black-butt timber. Before beginning construction and after looking at beds commercially available, I used the software Autodesk Fusion 360 to create an accurate scale model and animation of the design. This allowed me to visualize the final product, test measurements, and identify potential structural problems before starting production. Through online research into furniture joint methods, I determined that strong joinery would be essential due to the weight a bed frame must support. I selected black-butt timber for the visible external components of the bed frame due to its strength, density, durability, and resistance to wear, making it ideal for structural furniture. Its attractive grain and light colour also suit the modern aesthetic I'm aiming for. For the internal components and bed slats, I'd choose pine as it is lighter, more cost-effective, and easier to machine while still proving sufficient strength. Select grade timber was used to minimise knots and defects, improving both strength and overall appearance of the finished product. High-quality bed brackets further enhance structural integrity by securely connecting the frame components and preventing sagging or movement over time. Before gluing, I dry fit all joints using sash clamps and other clamps to check accuracy and allow for adjustments. After confirming a precise fit, I apply glue and then remove any excess using chisels and sponges, ensuring a clean finish and strong, well-fitted joints. A high-quality bed frame must meet both industry standards and consumer expectations. Structurally, it should be strong, stable, and able to support weight without bending or loosening, requiring durable materials, accurate construction, and strong joinery. To achieve this, I included a central support beam to prevent slat deflection. From a consumer perspective, quality is judged by appearance, durability, comfort, and ease of assembly. Features such as smooth finishes, aligned joints, strong fixings, and an appealing design is essential, which I address through the precise measurements and through sanding. Knockdown fittings such as bed rail brackets are also used to allow for easy transport and assembly. After purchasing the timber at Marshall's Timber, I decided to tackle the bed head first. I put the necessary timbers through the thicknesser to remove the exterior layer of dust and dirt and cut them to size and marked out the mortise. I marked out the bed cross rail for the 50mm tenon using a marking gauge to ensure all measurements were the same. Then I used a depth stop on the drop saw to create grooves for the tenon. I used a Japanese saw to cut down the height of the tenon, then used a chisel to carve out the rest of the tenon. For the mortise, I have used the pedestal drill with a 22mm flathead, drilling 3 holes per mortise, then using a chisel cutting out the corners and cleaning up the edges so the tenon sits nicely. Mr. Simmons helped resin all the beams with knots and imperfections using Jake's leftover resin. After finishing the mortise and tenon joint, I began sanding the dried off resin to create a nice smooth surface and began dominoing for the footboard to the legs using a sash clamp to dry fit. I soon glued the footboard together and using a chisel and some glue managed to get most of the glue off. After it dried, I gave everything a sand and started preparing for a support beam. My wooden bed frame demonstrates a moderate level of difficulty through precise design, material selection, tool use, and structural assembly, all requiring accuracy and skill. The use of mortise and tenon joinery adds complexity as it's time-consuming and demands high precision to achieve a tight structural fit. Working with black-butt further increases difficulty due to its density and hardness, which causes tool wear, increase the risk of splitting, and require careful machining. Additional challenges include designing the frame for disassembly using bed rail brackets while maintaining long-term strength and safety, managing glue open during large assemblies to ensure accurate and timely joins, and resin filling natural imperfections while still achieving a clean, high-quality finish. After reviewing store beds, I redesigned mine for a more modern, sleek look. Horizontal slats, flush posts, no raised foot, and a foot cap to hide the framework. I also resized the cross rail from 90x90 to 90x45 to reduce weight and cost while maintaining strength. So far, precise measuring, careful machining, and tight-fitting joints have ensured quality and structural integrity. For future projects, making prototypes, refining joinery, and improving time management could further enhance accuracy and efficiency. Thank you.